So up to this stage, we have shown that it is closed and it is commutative. Now the third step is to show the associativity. So इसके लिए हमें क्या करना होगा? We have to choose three vectors to let t1, t2, and t3 belong to the L of VW. Then we have to show that associativity. Then t1 plus t2 plus t3 of V. Now by definition, first this is equal to, अब यहाँ पे t3 plus t2 plus t3 is one mapping and t1 is another mapping. तो इसको by definition हम इस तरह से लिख सकते हैं, this is t1 of V plus t2 plus t3 of V. So this is by definition, because we know that t3 plus t2 plus t3 is also a linear transformation. तो इसको हम कंसीडर करेंगे एक लीनियर ट्रांसफॉर्म, इसको कंसीडर करेंगे दूसरी लीनियर ट्रांसफॉर्मेशन, एंड देन use the definition of vector addition. Now this is equal to, this is t1 of V plus, now again using the definition here, this is t2 of V plus t3 of V. But now here we can use the fact that W is a vector space, and since W is a vector space, and T1V, T2V, and T3V, they all belong to W because they are the images of the linear transformations from V into W. Okay, because these are the three images under three different linear transformations. So therefore, these three vectors, T1V, T2V, and T3V, they all belong to W, and W is a vector space. And once W is a vector space, it is associative. तो यहाँ पे हम अब associativity property use कर सकते हैं, associativity from W. So therefore, we can write this thing as, this is T1 of V plus T2 of V. तो यहाँ पे हम इस तरह से associativity use करेंगे, then plus T3 of V. And this is coming from, this comes from associativity of V, of W. Associativity of W. Because all these elements T1V, T2V, and T3V, they are the elements of W, and W is a vector space, so we can use its associativity. But now again using the same definition of the vector addition. तो इस पहले वाले को हम लिख सकते हैं, this is T1 plus T2 of V, then plus T3 of V. Now again using the vector addition. Now this is equal to T1 plus T2, then plus T3 of V. So therefore we have shown that T1 plus T2, T3, तो हमने brackets असल में change किए. So this shows the associativity. This shows the associativity of vector addition. ठीक है. Now next we have to prove the existence of additive identity. So that's the fourth step, to show existence of additive identity. तो additive identity दिखाने के लिए हमें क्या करना होगा? We have to find some linear transformation from L of VU and show that. तो अगर हमारे पास, हमें इस तरह से एक linear transformation चाहिए, suppose E is a linear transformation, or let's write the capital E, because then we have to show that E plus T is equal to T plus E is always equal to, हमें एक ऐसी linear transformation ढूंढनी होगी E which satisfies this equation. T इसको left hand side में add करेंगे T के साथ, या right में add करेंगे T के साथ, that should be equal to T. But since we have already shown that any two linear transformations are commutative. तो इसलिए e प्लस टी और t प्लस e अब अलग अलग से दिखाना जरूरी नहीं है, क्योंकि हमने दूसरे स्टेप में प्रूव किया था t1 plus t2 is same as t2 plus t1. तो इस तरह से हम सिर्फ दिखाएंगे there should be some linear transformation from in L of VW which satisfies e plus t is equal to t for all t belonging to L of VU. That is what we mean by saying that the identity element exists under addition. Now we know that the zero transformation is a linear transformation. जो हमने शायद पहले ही दिन किया था, zero transformation is a linear transformation. Now since we know that, zero transformation zero from V into W is a linear transformation. We have, तो पहले हमें एक लीनियर ट्रांसफॉर्मेशन देखनी होगी. नाउ वी विल शो दैट इट सेटिस्फाइज दिस कंडीशन. और इसके लिए हमारे पास क्या है, 0 plus t of v. Now this equal, now since 0 is a linear transformation and t is a linear transformation, and we know that the sum of linear transformation is also a linear transformation, so we can write this equal to 0 of v plus t of v. But 0 of v, ये linear transformation ऐसी है which maps everything to 0. So therefore 0 of v is equal to a zero element in w. इसको हम इस तरह से डिनोट करेंगे, 0 element in w is equal to 0 of w, then plus t of v. But now 0 of w is a 0 element in w and t of v is an element of w, so both of them are the elements of w, and 0 of w is an element. This is the additive identity of w. तो अगर w में additive identity किसी भी वेक्टर के साथ ऐड करेंगे, what we will get, this is same as t of v, क्योंकि 0 ऐड करने से कुछ भी चेंज नहीं होगा. So we have shown that 0 plus t is equal to 0 plus t of v is the same as t of v. So thus
T of v.
zero transformation is the additive identity. So zero transformation is the additive identity. Now the next step is we have to show the existence of inverse. Now next, to show existence of
Кода आपका ना
every element.
Yoga ne?
To show existence of inverse for every element t of L of VW. तो आपको क्या लगता है कौन सा एलिमेंट हम चूज करेंगे, कीपिंग इन माइंड कि वो एलिमेंट भी लीनियर ट्रांसफॉर्मेशन होना चाहिए. नाउ व्हाट वी विल चूज फॉर t so that its sum with that element becomes 0.
Negative transformation.
हाँ बिल्कुल, we will choose minus times t. Why we can choose minus times t? How do we know that minus times t is also a linear transformation? Can you give some explanation for it?
Minus 1 times t.
Minus 1 times t, because we know that alpha times t is a linear transformation. ठीक है? So
Sir, homogeneous property.
We can choose minus 1 times t belonging to w, noting belonging to not w, it is L of VU belonging to L of VW, noting that alpha times t belongs to L of VW for all. for all alpha belongs to F and T belongs to L of EU. तो पहले हम चूज करेंगे, लेकिन अब हम प्रूव करेंगे दैट इट इज द इनवर्स. नाउ माइनस टाइम्स माइनस
सर,
1. हाँ बताइए.
जो पहला वाला पेज है ना, इसमें लास्ट हम स्क्रीनशॉट ले.
हाँ ये है पहला पेज, तो आप लीजिए स्क्रीनशॉट.
दूसरा वाला 5th.
नाउ दिस द सेकंड पेज. हाँ
ओके सर.
okay, now we will show that when we can choose this minus 1 times t, it is again a linear transformation. Then plus t, we will show that this is a zero transformation. Now this is equal to, by definition, this is minus 1 times t of v plus t of v. Now this is equal to minus t of v plus t of v. So this is the image of t under v, and this is the image of t under v, and they are the negatives of each other. So this is clearly the zero of w. So thus inverse of t belonging to L of VW is minus t. तो इस तरह से हमने प्रूव किया अब existence of inverse भी. So thus we have shown that L of VW is an additive abelian group.
Show that
additive abelian group. Now we have to show the properties of vector addition in respect of the scalar multiplication. ठीक है, और मुझे लगता है वो अब हम बाकी कल करेंगे, because now we have only 5 minutes left and you also have to attend the next class.